Let's review one of these problems from class. Here we have a normally distributed data set, and we know the average after many measurements. We have an average for these tablets of 50.1 milligrams of drug per tablet, and we know the standard deviation for this data, 0.87 milligrams per tablet. So it's in the same units as the measurement itself. We're asked about what fraction of tablets fall below a line set at 48 milligrams per tablet. In other words, we want to know what a percentage of the population falls in this wing right here. So what percent fall in that wing? We have data on we know how to connect data to the z values, and the trouble is the table uses areas in this shape. In other words, between the center or the average value and our value x. We know those distances based on finding the corresponding value of z. We can come up with those areas. Well, the blue area and the red area sum to 1/2. So if we want to find the area in blue, we'll call that the area of interest. The area of interest is equal to the half of the total curve of the population minus the area from the table. Now, to get the area from the table, we need to be able to calculate z. We know that z is equal to the difference in the average value and our value of x, that absolute difference divided by this sigma, our standard deviation. So we have numerical values for that. Let's plug them in. So it's 50.1 milligrams minus 48.0, and we divide by sigma, which is 0.87 milligrams per tablet. This gives us a z value of 2.413 standard deviation units. Now, we go to the table for z, and we find that there's not exactly what we need listed in the table. There's 24.4 or 2.4 and 2.5 are the nearest values. So we're going to have to interpolate this table. We know that the area that we're interested in, or at least the area in red, that area should be the bottom area value plus some. And it's going to be a fraction of this interval in areas. What is the fraction? It'll be the same fraction as represented by the actual value of z that we want and this interval. In other words, it's the difference between 2.413 and the lower table value of 2.4 divided by the interval in the table. And each value in the table is 0.1 standard deviation units different. So this times the difference in the area represented by our two areas associated with these closest z values. So what is that difference? Well, it's the bigger value for 0.4938 minus 0.4918. Okay, when we take that, do all that arithmetic, we find that that area in the table is equal to 0.4940, and the next digit would be a 6. So that's the red area. To calculate the blue area, then we need to subtract that from 1/2. So the area of interest is 0.5 minus 0.49406, and I get a numerical value of 0.0059, and the next digit is 4. Or that says that the percentage of the total population is 100 times that value, or 0.594% of the total population in that blue wing.